A consumer-grade piece of electronics with Ethernet and Wi-Fi, ready to take your Bluetooth packets up to the cloud. Welcome back to Life. I'm Chris, and I'm here with my friend Mike, and we're going to be going over gateways today. How you doing, Mike?
I'm doing pretty well. I'm excited to have a consumer-grade piece of hardware up on the Goliath platform.
Right, and you made it all kind of get up and going. This is a piece of hardware that we've been looking at for a while. It's actually meant as a Matter gateway. So this is from a company called Globalscale Technologies. And so the GTI-RW612 is a gateway that is meant for Matter. It's a consumer grade piece of electronics. It's got Ethernet, it's got Wi-Fi, it's got a thread radio, which we're not going to use here, and it's got Bluetooth. And their mic's showing it on screen. So there we go. Yeah, and button, speaker, screen, things that probably most of our dev boards wouldn't have had, kind of native on board. So what did it take to actually get this going, and what does it look like on the code side of things?
Yeah, so it didn't take a ton to get this going because we just added it to the Goliath Bluetooth gateway code. And if you're watching, when I started it up, it said connecting, and now it's showing the Goliath logo, which means it has already connected. And we see the session was established a few seconds ago. I also have over here to the side a little Bluetooth dev board that's running our pouch demo. And so we see that that's already connected to the gateway. We have a little topology map over here for that, and we can actually go over to it and see the data that has been coming in from that sensor, which is just a little bit of simulated temperature sensor data.
Yeah, that's awesome. And the stuff that comes from the manufacturer is actually, again, meant for this off-the-shelf Matter gateway. So the firmware you get from them is that you had to then port it to Zephyr and utilize a lot of the stuff that's already in Zephyr for the RW612, which is the chipset from NXP. So what does that actually look like then to migrate that and make it compatible with this hardware?
Yeah, so that was actually pretty easy because we were already using the NXP Freedom RW612 dev board. And so on this, if we reboot the device here, one of the things that I had to do is just get MCU boot up and running for this particular device because it is a little bit different hardware. I think the flash chip is different from that RW612. But we were able to get that up and running. So we have application version right here of 1.2.0, which is the MCU boot. That makes it possible for us to do device firmware update locally on this, as well as if we wanted to, we can push it down from the cloud. So in addition to being able to push firmware uploads to your Leaf nodes, you could potentially push them to your Bluetooth gateway as well.
Great. Yeah, and that is definitely one of the big benefits that we wrote about in today's article that this video is going along with. You can see the link to the article down in the YouTube video, if your YouTube description, if you haven't already seen that. So we kind of described a little bit more about what's going on here. In terms of the MCU boot, I remember you talking about when you were getting this going, the fact that you had to, this is a consumer grade piece of electronics. It's not the easiest thing to open. It's not meant to be open, really serviceable by users. And so that's why you enabled it with MCU boot. So you could then send stuff over USB as well.
Yeah, so the one thing that I had to do is open the case, which it is, like I said, like a consumer grade product. So there's no fasteners around, and it meant that the double stick tape that's holding the faceplate on had to come off in order for me to program that initial bootloader on there. And I have it set up so if I hold one button and press the reset button, I don't know if you can see this, if there's a green light that comes on inside indicating it's in bootloader mode, and through the USB port you could push firmware to that. Now if you're going to market with something like this, contacting the company and making sure that it comes with the bootloader that you expect on it is something you could definitely handle in the production process.
Yeah, that's great. That's great. Yeah, and so, like you said, one of the big benefits of doing this sort of thing, one of the reasons we talk about microcontroller-based gateways in the first place is the idea of having a updatable managed device on Goliath. So now, like Mike said, he can push an update down to this device. As we've shown in past blog posts as well, you could actually add additional sensing onto this device. So you wanted to, there's actually some external plugins on the side there. I think there's some analog sensor plugins as well. We haven't done anything with that yet. There you go. Yeah, so it's got a connector there for that sort of thing. temperature sensors on board, other things you might want to be doing logging locally on this managed device for the gateway, you could also push that data up to Goliath. You could add up logs, send up logs, you could send commands down to it, that sort of thing. And that really opens up a wide array of capabilities on a gateway, whereas you might just think of it as a pass-through device otherwise.
Yeah, I think you're right on that. And just the ability to do a little bit more with the gateway, there's not a ton going on. It's like we're not using a lot of the resources for the flash or the horsepower on the chip, just because, like, for instance, the packets from Pouch coming from the Leaf nodes, they are encrypted, but the gateway doesn't decrypt them. The gateway just
Right.
passes them on up to the cloud. So this is a great case where if you had some other sensing that you need to do in addition to your Leaf nodes, that you could add that to the gateway in your code. It's part of the nice thing is that we're not locking this code up as proprietary. It's open source and available for you to do with as you need.
Yeah, that's right. Yeah, and you weren't kidding about horsepower. That thing has the main application processor. I was looking at it. It's like a Cortex M33, which we're used to. We've used those a lot, but clocked at 260 megahertz. It's like, oh, okay. Yeah, that might be a little bit more than we need. I don't know. It's a little zippier than we're used to. I'm like,
Yeah, I felt a little bit silly putting like some graphics on the screen on this and making it blink. I'm like, this thing is so much more powerful
I
than
know.
this. But I'll tell you, it is really handy to have everything already worked out for the Ethernet. So if you have an installation where you have Ethernet available, it is built into Goliath, built in through Zephyr. You just plug the cord and it works, and that's pretty awesome.
Yeah. Speaking of display, that is LVGL that's running the display on there. Is that right?
Yeah, that's right. It's a neat little library if you haven't tried it before. You can run animations. Like I said, I just did a little bit of text to let you know what's going on. It'll tell you if your gateway is not provisioned, which is pretty helpful when you plug it in, and it'll tell you if it's not connected because it'll say it's connecting.
Awesome. Well, great work on that, Mike, and excited to see other gateways that we highlight here on Goliath as part of Goliath connectivity. That is what enables Bluetooth devices to connect to the cloud, get things like OTA, get settings updates, send up streaming data to the cloud. All of those things are possible, and all of this is possible because of Mike's good work on the firmware side and building on top of Zephyr. So thanks, Mike. We'll see you on the next one.
All right. See you later, Chris.